Hello and welcome back to the third part of presentation on chapter radar systems of the subject microwave and radar. In this presentation, we'll see the radar beacons or the racons, and we'll see the sonar system working principle and applications. So first, let's see the sonar. What is sonar? Actually, sonar is an acronym of sound navigation and ranging. It is a technique that uses sound waves to map or locate objects in the surrounding environment. It has been in use by some of the animals like bats and whales for millions of years, and Leonardo da Vinci was the first person to perform this ingenious experiment. What he did was he inserted one end of a tube into an enormous sea and put an ear to the other. Then the vessel sounds, different vessel sounds could be heard on the other end of the tube. With the knowledge of the speed of sound, that is approximately 1480 meter per second under normal water condition, and the time that passed before the wave was retrieved, an adroit receiver can calculate the object's distance from the emitter. Sound waves tend to travel longer distance in water than in air. In open air, its speed is 343 meter per second, and hence more effective with waters. So sonar is more effective in waters as the sound is traveling faster in underwater. So sonar that is used by NOAA, that is National Oceanic and Atmospheric Administration of America, US, to develop nautical charts, execute seafloor mapping, locate shipwrecks, and predict underwater hazards. Even doctors use to detect cysts and cancerous cells using ultrasonography. So Sonar's patent was sanctioned after the tragic Titanic sinking in the year 1912. So military, it is also used in military field to detect, identify and locate submarines. So there are many applications of the sonar. It can be used to detect other vessels, to measure depth of water. It can be used for searching oil on land. It is used for searching means of aquatic location. Then in robot navigation, it is used to identify the areas of oil gas, used for seismic explanation, and many more applications are there. So let's see what are types of sonar. There are two types, basically active and passive, and one more is included for acoustic communication system. So what is active sonar system and passive sonar system? Let's say in active sonar system, an acoustic projector, the transmitter is having a projector that generates a sound wave that spreads outward and is reflected back by a target. A receiver picks up and analyzes the reflected signal and may determine the range, bearing and the relative motion of the target. Whereas a passive system consists simply of a listening device or receiving sensors that pick up the noise produced by the target, such as the ship, submarines or torpedo, or even the movement of big fishes. So waveforms thus detected may be analyzed for identifying characteristics as well as direction and distance. So the adjacent diagram shows the two types, active and passive sonar. Whereas the third type, the acoustic communication system, which require a projector and receiver at both ends of the acoustic path. So for a sonar at a low frequency, say below 20 kilohertz, it generates poor resolution, but they boast of higher ranges as are less attenuated by the obstacles in between. On the contrary, if the high frequency sound waves are used, that is greater than 100 kilohertz, then it generates a phenomenal resolution, but drawback is that it is prone to heavy attenuation. So with a low frequency, it is having poor resolution but long ranges, whereas for high frequency it generates better resolution but heavy attenuation. Now let's see the radar beacons. What is a radar beacons or racons? It is called a radar beacon is a small radar set consisting of a receiver, a separate transmitter, and an antenna which is often omnidirectional. When another radar transmits a recorded set of pulses at the beacon, that is, it interrogates it, the beacon responds by sending back its specific pulse code. The pulses from the beacon or the transponder, as it is often called, may be at the same frequency as those from the interrogating radar, in which case they are received by the main station together with its echo pulses. They may alternatively be at the special beacon frequency, in which case a separate receiver is required by the interrogating radar. Note that the beacon does not transmit pulses continuously in the same way as the search or tracking radar, but only responds to the correct interrogation. The operating frequency could be 9320 megahertz to 9500 megahertz, that of the X band, and 2920 megahertz to 3100 megahertz of the S band. So the responding time is taken by the racons is 25 microsecond. Long signal within a time of 700 nanosecond, it is responding when interrogated properly. So what are the applications of radar beacons? There are many applications. Beacon may be used to identify itself. The beacon may be installed on a target such as an aircraft and will transmit a specific pulse code when interrogated. These pulses then appear on the PPI of the interrogating radar and inform it of the identity of the target. The system is in use in air traffic control and also for military purposes, where it is called identification friend or FOI, IFF. Another use of a radar beacon is rather similar to that of lighthouse, except that radar beacons can operate over much larger distances. An aircraft or ship having interrogated a number of beacons of whose exact location it may be unaware on account of being slightly lost, can calculate its position from the coded replies accurately and automatically. The presence of a beacon on a target increases enormously the distance over which a target may be tracked. Such active tracking gives much greater range than the passive tracking so far described, because the power transmitted by the beacon, modest though it normally is far in excess of the power that this target would have reflected had it not carried a beacon. So here we see the radar beacon as lighthouses, similar to lighthouses, and the radar beacon used for air traffic control and for interrogating a target. So the other applications includes and the to identify the aids to navigation, both seaborne or land based, to identify the landfall or position or navigable spins under bridges, oil to identify oil platforms and similar structures, to identify and warn of environmentally sensitive areas such as coral reefs, to mark center and turning points in navigation is to identify itself the place where it is located, and air traffic control and also for the defense purpose. Thank you for patiently listening.